Okay. Good morning, ladies and gentlemen. Welcome to the third session of our Masterclass series on the future of auto and helping the broader public understand some of the dynamics and what we're going through as an industry. This is the fourth session and last one in this series. We announced when we started that this whole entire series is dedicated to the life of Brand Pretorius, who's our champion for this particular year of the Masterclass series. Historically, if I were to do a quick recap on how and where we are in this particular series, you would remember that we started it about 8 weeks ago. And in that period, we looked into a leadership masterclass around what it takes for leaders to succeed in a changing global environment that's impacted on by geopolitical instability, that's impacted on by shifting economic variables that would affect trade and technology advancement. And we went through a whole lecture around how to master those global shifting realities in the continent. But not only did we leave our conversation at that high hypothetical level, but we brought it down to what everyday entrepreneurs are going through. So we had a conversation with the CEO of West Bank, Mr. Ganam Sidi, who then gave us the insights from a bank and how a bank is adjusting to technology shifts and what has been some of the responses that they had to adjust to, so that we have we can take practical lessons from a champion who's in that particular field and how they're making the adjustments. Then we also had Andre Redboy with us in the last session. And during that particular session, Andre looked into what it takes for an entrepreneur to mature their business from a startup all the way to being a tier one supplier. What are the type of mental adjustments that are required? What are the type of technology adoptions and technology learnings that are required for someone to then make that journey and become a full tier one supplier within the auto industry in SA? And Brand gave us a masterclass. I think he gave us a library of key insights and nuggets around what it takes to be a leader in this, to be a leader generally an entrepreneur in the South African environment. And through that lesson that we got from him, we were able to effectively learn how to approach what he called the technology tsunami, how to master and manage our own productivity, and how we are responsible for that process of managing our own productivity. And today we come into a very interesting conversation because we're going to look into the manufacturing sector in SA. We're going to look at where the manufacturing sector is moving towards. The auto industry in SA is responsible for some 25% of productivity in the manufacturing sector, but is responsible for a significant amount of exports that are manufactured. I think we're responsible for just north of 45% of exports that are manufactured in South Africa, at least in our auto. And so we are a very big role player in that manufacturing space as an industry. But where is this? What are the opportunities? Where is this sector going? What is the future of manufacturing? Where are the opportunities? What is the new language that is driving this particular next phase of manufacturing in the country? And to help us navigate that conversation, we've invited Dr. Christopher Wilberforce, Tabi Wilberforce, who's a lead professor at the University of London, and to give us insights from and learnings from the UK environment, how UK shifted their skills development initiatives to adjust to the changing profile of the product that they were producing, especially LEVs, and to look into some of the dynamics of how their society made adjustment to move their manufacturing processes and manufacturing education towards this desired end. Following him, we will then have another presentation by Mr. Kotsia from the CSIR, who then give us some of the technologies that they're dealing with. We'll learn about learning factories and how learning factories are shaping skills development for the future of South Africa, some of the languages and technologies that are being developed to sustain a manufacturing future for the country. And then we'll then go into a conversation with Professor Grace Kanakana, who will then give us a TUT, a local institution in South Africa. What are they doing to then sustain and support manufacturing and the future of manufacturing in SA. So without further ado, I'm going to ask Dr. Toby to Wilberforce to take the center stage and to start sharing a presentation. Like as I said, he's a lecturer at the University of London in the School of Engineering, and he's going to take us through that particular background of the UK case study to help us understand how we got to where we are. Thank you.
A very good morning. No, please go ahead. Sorry. Go.
It's your stakes.
Hi, good morning. I can go on. Okay, so a very good morning to everyone, and many thanks for joining us. I'd like to put my presentation up. Right. Okay. So thank you very much, everyone, once again for joining. Can you hear me? Is my audio very clear? Am I laudable enough? And let me set my time. Okay, perfect. So that I don't go through my time. Okay. So this morning I'm here to present the UK perspective on the future of manufacturing and skills development. But to begin my presentation, I'd like to give some bits of background about myself. So I'm currently a lecturer in engineering education at King's College London, but prior to joining King's, I was the deputy program director for mechanical engineering at Aston University. But my whole career started from Scotland at the University of West of Scotland, where I was a lecturer in mechanical engineering. And in the last couple of years, I've been able to accrue nearly 3.8 million in funding for various projects across different funding bodies here in UK. And my area of interest in research has often been around hybrid powertrain, hydrogen fuel cells integration into the automotive industry, and engineering education, that is project-based learning, and CDIO, that is a form of teaching philosophy. Most of the projects I've done cut across different funding organizations, that is British Council, UKRI, and these funding bodies that is presented here. So in the next 30 minutes, I'll be touching base on UK manufacturing industry at a glance, narrow it down to the automotive industry contribution to the manufacturing industry or sector, look at the manufacturing value chain as a whole, some skills challenges that we are facing within the UK, and how digitalization is helping to mitigate some of these skills deficit, and some lessons learned. So I would like to begin this morning's presentation by reflecting on the global manufacturing market and its current stance now. Now, the market is now worth 6.7 trillion globally. But when we narrow it down to the UK, we have about 5.5 million small and medium-sized enterprise. Now, these enterprises are basically businesses that employs less than 250 people. But these 5.5 million small and medium-sized enterprises account for nearly 99.9% of businesses in UK, according to statistics in 2023. When we narrow it to the manufacturing organizations, we have 269,000 number of manufacturing organizations in the UK. And out of this, 250,000 of them are SMEs. And that constitutes 5% of the total businesses in UK. Now, what does this mean? It means that SMEs are basically the lifeblood of the UK economy, as well as the manufacturing industry. Why? Because it employs 9% of total number of people who are unemployed in UK. And at the end of the year, there's 14% of turnover. Now, there has been some decline in terms of the manufacturing industry compared to statistics in 1970, where it contributed to 25% of the UK GDP. Now, if we want to also reflect on some data gathered in July 2024, the UK manufacturing industry is currently the 8th largest manufacturing industry in the world, contributing about £212 billion as GVA to the economy, which is about 11% of the UK GVA and 45% of UK export. If we want to narrow it down to the number of people the sector employs is 2.6 million. That is the number of people the sector employs. And these people earn averagely around 38,000 to 40,000 pounds in a year. And in terms of private investment, it provides around 38.8 billion as total UK business investment. If we compare it to other sectors as well, we can see that the manufacturing industry is the third largest contributing sector to the UK economy. Now, someone will ask, why am I providing all these statistics? Why? Because it gives value and significance to how the UK manufacturing industry is contributing to the successes and the economy of UK. If we narrow it down to the automotive industry, the industry employs about 198,000 people, and across the entire sector, it has a total turnover of around 93 billion, and this is 22 billion in terms of GVA contribution. And the industry also accounts for 12% of the total UK exports in terms of goods. And also in a year, there are about 4 billion research and development investments within the sector. Now, what does this imply? It implies that this is also another hub that contributes to the success of UK's economy. Now, in order for us to appreciate where we are in terms of manufacturing, we need to first look at the value chain. Now, when we look at the value chain for manufacturing, everybody is now talking about reuse, remanufacturing, recycling, because from the production of any product at all to the end user, there is the need for us to also reconsider how these processes affect the various dynamics in terms of efficiency of the system that is being used, in terms of where even the final product is likely to end up. So everybody is talking about the circular economy and how the UK is transiting towards its manufacturing industry in that light. So for us to understand the value chain, we need to also dissect it into various fragments. We need to appreciate the contribution of the manufacturer, the users, the remanufacturers, and even the society as a whole. But within the UK, we face a major challenge. One of them is the fact that there is always a shortfall due to the aging population within the sector. And that's tend to affect the demographics holistically. Again, in terms of the education and skills training, it is very much fragmented, which has also been reported as a major issue that is affecting the industry negatively. And recently, there is digitalization, which is being recommended as a whole. The other issue is how we can build up the expertise base within the country. Why? Because there's a lot of technology that is coming up, and every now and then there's the need for upscaling, there's the need for people to go through different forms of training. Again, there's also poor demand alignment across the sectors and also the technologies that is coming up. So everybody is now talking about AI and how AI can be integrated into the manufacturing industry. But across the world, solving some of these challenges does not only reflect on the manufacturing industry solely. It is a mixture of everybody coming together to put up their bits and pieces. For instance, as an academic institution, there is the need for us to work hand in hand with the industry to be able to first appreciate some of the challenges that is in existence and how we can remodify our curriculum and content to mitigate some of these skills deficits. And again, there's also the other aspect that involves the government also coming in to provide that needed support. The other thing is also looking at learning factories as an educational model, which can also help integrate digitalization. And also for us to look at the funding that can help in developing some of these skill training activities. So looking at the UK manufacturing sector, one of the things that we can do in order to maximize the potential of the UK manufacturing sector is leveling up the whole UK. That means in terms of infrastructure, there's a need for us to, sorry, thank you. So there's a need for us to look at how best as a country we can develop more infrastructure to meet some of the skill demands and some incentive being made available to various manufacturing players. Again, achieving net zero is also another issue that is really making a lot of noise in the UK, where most manufacturing industries are being recommended to look at their carbon footprint. In terms of building a science superpower, more R&D activities is also being required, and that is also being championed at the government level. Again, designing and maintaining world-class regulatory framework is also important in order to push the sector forward. And finally, supporting international leadership, it's also another requirement in order to push the manufacturing industry in UK. So the next item that I'll also talk about is the digital transformation in manufacturing. And this is also another area that the country is gradually drifting towards. And why is this important? Because digital transformation can help boost productivity. And at the same time, once we automate a system, it's tends to improve the efficiency of the whole process that we are looking at, whilst mitigating erroneous labor-intensive process. Again, automation can also enable round-the-clock production without the need to break or shift changes. And with the integration of AI and machine learning, we can drive smart automation, and that can help us easily do sophisticated activities. Again, advanced tools in order for us to achieve high precision production process is also a need that is requiring the need for digital transformation. And lately, there's also some conversation about IoT and how that can also enhance decision-making in manufacturing. And by this, there's a lot of different IoT devices and sensors that is coming up in terms of collecting data. And out of that, we can easily understand the operation of a system. And so digital transformation is really reshaping manufacturing whilst replacing linear production model, making it more agile and more interconnected. Now, these technologies include digital twins, robotics, automation, and advanced data analytics. Now, robotics and automation over the years have actually evolved to handle complex operations because of digitalization. So how has this improved production? One of them is customization and flexibility. Once we introduce digitalization, we can produce lots of items at scale and personalize whatever we are doing to meet end demand. Again, in terms of supply chain integration, it can help in effective management of the process. And with the introduction of cloud-based computing, that can also enhance collaboration. Now, what are some of the impacts and why digital transformation is very critical? The first one is sustainability. So everybody is talking about how best industries can reduce the waste across their supply chain. And with the introduction of digital transformation, that can be an active solution to that. Again, in terms of the workforce, the approach in which existing workers could be trained and upskilled to meet growing technology is also another justification for why digital transformation is important. And in order for us to compete globally, there is the need for us to also adapt to the changing times, and that is where digital transformation also comes in. Now, what are some of these technologies that is coming up? One of them is cloud tech, 5G, blockchain, additive manufacturing, edge computing, a host of others. And all these are geared to make the entire manufacturing process more efficient, less time consuming, and at the end of the day, us having product that is fit for purpose. So in terms of some of the merits, one of the merits of introducing digital transformation is to ensure that there's improved product quality, that is precise manufacturing. Again, it tends to enhance operation in terms of efficiency through automation, predictive maintenance, optimized use of resources, and improve customer experience. Again, in terms of sustainability, there's waste reduction and supply chain resilience. But there are challenges. Even though the UK as a country is drifting towards digitalization, there are notable challenges in relation to financial constraint and ROI calculation. There are also some elements of cultural resistance to change. People that are already in there using the traditional form, finding it difficult to embrace the new technologies. There's also a skills deficit, especially with the growing population always entering retiring age. Replacing them is gradually becoming difficult. There's also issues about data security and privacy, integration of legal systems. Now, as a solution to mitigate these challenges, there should be some clarity in the ROI through feasibility studies. And again, the training is being requested to be more targeted. In terms of the training, to mitigate this skill gap, it should be more robust. And in terms of the upscaling, it should be more targeted towards the need of the manufacturing sector. Again, introducing new system or technology should be more or less like a middle ground between the old and the new technology, so that constantly there can be that element of communication between the two parallel streams that is going to be in existence. If we just change directly from the old to the new, then the transition process is always going to be difficult. And again, the need for cyber measures is some of the means that we can mitigate some of these challenges. Now, one of the key things in the manufacturing industry at the moment is net zero, and how various organizations can meet this growing government demand. Now, in terms of recent study that was carried out, 25% of Britain's manufacturers believe that new technologies can help in decarbonization of their sector, but 39% of them believe that climate change and net zero is going to become a priority in the next 3 years. So whether they like it or not, it's a change that they need to be embraced. But 82% of the businesses say that their ability to follow this change is subject to how government also contributes in terms of its climate change quota to mitigate some of these numbers. So now green in UK is no longer something that industrial players just talk about, but it has become a requirement. And again, it is one of the drivers that companies are beginning to embrace to have a huge impact in terms of their investment and in terms of even the output of whatever manufacturing industry they find themselves. Now, 47% of manufacturers at the moment have plans in place to ensure that digital technology is integrated into their business chain to reduce their carbon footprint. And 24 of them believe that investing in digital technologies would significantly boost their business output. But half of them said that digitalization was a top productivity improvement that their businesses are currently piloting. So what are some of the key challenges? The first one is the supply chain emissions. Now, in the UK, most of the emissions from these manufacturing organizations is categorized into scope 1 to 3, where the scope 1 is more about the emissions directly from the company, and their indirect emissions from the company is also considered as scope 2, but the overall emission across their supply chain is considered as scope 3. Now, 70% of carbon emissions from these companies originate from scope 3. And that is one of the difficult bits that most companies are struggling to meet this government requirement. The other thing is the fluctuations in inflation and interest rates across the country. So financial investment is also another major issue that is affecting the sector. And again, finding right skill, because within the UK, the average age of manufacturing operative is now over 50 in terms of having that skill requirement. So how do we mitigate this? The first one is for us to appreciate that net zero is not something that should be done in secret or in hiding. So sharing and learning is also very critical. Again, manufacturing industry is expected to measure and monitor their carbon footprint. The other thing too is about sustaining skills. So the need for upscaling, the need for training, and good use of financial support. So government interventions should be judiciously used for right purposes. Again, there's also the need for us to make good use of experts around us, whilst also monitoring and evaluation best practices across the sector. We need to also hire net zero champions who will be able to push the sector towards decarbonization of the sector as a whole. And finally, the need for a community of practice. So how do we meet this skill gap? One of the conversation that is also going around is the introduction of augmented reality. In the face of manufacturing industry struggling to attract, retain, and train workers, this technology can easily help manufacturing leaders to be able to upskill their workers at a reduced cost. Now, most industrial players prefer this as against the paper-based training method that has been done in the past. Now, why is this critical? Because in 2021, there were about 420,000 workers that was lost to the sector, according to the industry week. Now, if we are losing this number of people, then the next thing is how best can we replace them? And the use of augmented reality is one of the areas that is currently being recommended. So the question is, why augmented reality? It is one of the means that we can easily capture the expertise of veteran, skilled workers, and distribute it in terms of the context that we want to present to the trainer. Again, using augmented reality can also reduce the task involved by limiting the number of interruptions in the studying process for the trainer and gives workers the information directly relevant to that step. Now, at the end of the day, there are two results that we are likely to have. We will end up with workers that will be more efficient, and again, that will be able to get things done according to instructions given to them. So the overall introduction of augmented reality can be combined on-site or remotely in order to upskill workers within the manufacturing sector. Now, what are some of the impacts that it can have? It helps organizations to see concrete results in terms of machine operator training, field service, remote assistance, procedure training, etc. And again, it can help in generating reports in relation to training faster in terms of greater knowledge retention, more accurate and efficient skill. Now, we acknowledge that augmented realities platforms are becoming a bit complex, centralized, and customized system oriented. But with the use of other technologies like the 5Gs, the new upgraded mobile technologies, this reality can be achieved, which is currently being piloted within the manufacturing sector in UK. Now, in terms of leveraging mobile operators to support AR, we are at the moment realizing that this is one of the key requirements if any country want to gear towards maximizing its manufacturing industry. Why? Because with the integration of 5G, it's gradually becoming a paradigm shift. Why? Because again, there can be cost-effective data intensive devices that is being produced. We can also leverage 5G for real-time AR use and optimize the building of augmented reality deployment without being hobbled by network cabling. And again, we can extend data-intensive AR solution to remote locations. And all these highlight the synergy between augmented reality and the current transformation in the mobile operators sector. But in terms of statistics, at the moment, a survey that was carried out came out with some results where 71% of employee training effort is believed by manufacturing leaders to be a game changer in the manufacturing sector using 5G as benefit. Again, 84% believe that condition-based remote monitoring for predictive maintenance was achievable as a result of the development of 5G. And 82% also agreed that preventive maintenance can significantly be improved with the introduction of 5G. Now, what does this mean? These leaders that were interviewed for the study anticipate that in terms of equipment production, there's going to be a 42% increment, whilst in terms of work productivity, this is likely to also increase by 41%. So what does this simply mean? There is a brighter future in terms of the manufacturing industry, but we need to begin to embrace some of the changes that is coming up. Why? Because the sector continues to lose its workers and skill force, and the need for retraining them should be aligned to the technological advancement that we currently have. So the loss of skills we know is unprecedented in a very tight labor market affecting manufacturing leaders. And one of the proactive measures is the use of AR in order to upskill this deficit knowledge gap within employers in the manufacturing industry. And with that, there's no need for any infrastructure work once we decide to introduce the 5G and the AR in order to make manufacturing stream more efficient. On that note, I'd like to say thank you very much for the audience, and I'll wait for the question time or session. Thank you.
Thank you. Thank you. That was so insightful. That was so insightful. Ladies and gentlemen, I want to invite you for your questions and answers. I appreciate all the applause that we're receiving for this presentation. If you could post your questions in the Q&A box, so that later when we have our Q&A session, you can then get a chance. You can then get a chance for Professor Dr. Weber, of course, to answer those particular questions. So please do share your questions in the Q&A box. Now, without wasting time, I'm going to ask our colleagues from the CSIR to share the screen. And I'm going to ask Mr. Rian Cotier to share the screen. And what we will then have at least it's a deep dive into the technologies that we've just learned about, and to see where we are as a country and what capability and how well we build our own capacity as a country around the same technologies, and how to partner with institutions such as the CSIR for our own industrial development. So Rian, if you could share your screen and open your camera, that would be appreciated. Thank you.
Hey, can you see my screen?
We can definitely hear you, but there was not like your screen now.
Okay.
There we go. Be live.
All right. Good morning, everybody. Thank you for the opportunity. My name is Rian Cotier. I'm heading up the Future Production Systems Group at the CSIR. That's part of the Center for Robotics and Future Production. I'm just going to talk a little bit around the Center for Future Production at the CSIR. As you know, the CSIR has been implemented by Act of Parliament to support the industry and help them, help them with their production efficiency and improve the quality of life. Our group specifically looking at digital transformation, and we look at production optimization, 4IR skills development, robotic platforms, intelligent production and monitoring of systems, and then creating market-ready products. We are basically three groups. I'm heading up the future production, and then we've got industrial AI and industrial robotics. This is just to give you an idea from technically where we are coming from. We've got four core platforms that we support for industry. The first one is the Learning Factory, and I'm going to show a video a little bit later to explain where the Learning Factory fits in. The Smart Factory, which is a kind of a replica platform where we can simulate a cell from industry in a kind of a safe environment where we can then implement technologies. And then we also do a lot of product development, machine design, machine automation, etc. And then customized robots, from robots that are roaming in vineyards right through to AGVs, etc. So that's just from the group that at the CSR. I want to talk about digital transformation, like the previous speaker, and this is one of the key things and probably most misunderstood area that people look at. They just think it's just automation of processes and communications and data. But if you look at the definition, it's really the integration of digital technology. And I think the key thing is that the digital transformation needs to lead to an increased engagement in your customers. You create a better environment, a better product, a more connected product for your customers. You optimize your operations through that same process. You transform your product so that it can have more than one income stream, and you empower your employees so that they're able to create these kind of complex problems that are engaging with your customers. So digital transformation is core to your business model. And the golden rule is you never go on a digital transformation process unless there's a business case for it. Never do it for the sake of technology. It will always backfire. All right, then just some key considerations. The world of technology has become a lot more complex. It's not just about implementing technology. You need to look at a couple of factors that have an influence. The risk of failing a new technology is a lot greater. We've seen some good technology trying to be implemented in the wrong environment in South Africa, and it backfires. And 3 months later, the new technology is standing in the corner, and people are bypassing it. So there's a couple of key things that you need to understand in implementing technology. And the first one is the maturity of the technology, making sure that it's not just a hype cycle that you're going through, that there's real value behind it. So it's important to understand where that technology is currently. You also need to have a holistic view of your company. Technology are not just products anymore that are standalone. They're integrated into management system, and they integrated into the culture. And I think somebody once said that culture, eats strategy for breakfast. So it's very important that you get the buy-in of every level in the company. You also need to understand the minimum requirements for the technology. You can't implement a digital twin unless you've got connectivity on the shop floor. The technologies are starting to building onto each other, and you can't just jump from one to the other. You need to have some basic stuff in place. And then the key thing that we realized after 20 odd years of technology implementation is that future skills training and training of people in your company is extremely important. And the technology will survive or die based on skills training. So that's why we basically created the South African Learning Factory. Just the maturity of technology. This is what they call the Gartner hype cycle, where it starts with the innovation trigger. And you can see here you've got federated learning and AI. And at this stage, it's still very immature technology. It then goes to the hype curve where it's at its highest. AI, augmented reality, is at that stage where they look at generative AI, etc. And then it goes through the trough of disillusionment, and it's only here where it actually becomes useful. So if we look at the same technology hype and we look at the adoption rate, the people usually adopt the new technologies are new innovators, startups, and then you've also got the early adopters that catches the technology here at the peak of inflated expectations. And this is what we typically call the pioneers. and they are pioneers because they end up with most arrows in their backs. They learn the hard lessons. The ideal is to be the early majority where the technology becomes useful, and you can realize real benefits from that. The other option or the other area that you need to look at is holistic view. And here we use the Singapore Smart Industry Readiness Index, in short, SIRI, to look at holistically at your company. And at the highest level, you've got processes, technology, and then the people or the culture side. And on the processes side, you need to look at your supply chain operations, your product life cycle, and need to look at the vertical and horizontal integration. So any new technologies that's going to be implemented, you need to understand the knock-on effects on the processes in your organization. Then on the technology side, you need to look at what does your connectivity look at your shop floor, on your enterprise level, on your facility itself. And before you can implement any automation or even intelligence, this is the prerequisite that needs to be in place. You can't go directly to intelligence if there's no connectivity and automation. And then the most important part, and this is what we always get, is that you need to look at the workforce development as a strategic lever, and then also your leadership competency, because your management team needs to know what are the benefits of the different technologies. And then obviously there needs to be a strategy around it, and there needs to be collaboration so that there's no silos. So you need to have the holistic view of what will be the unintended consequences if you implement certain technologies. Then the other part is the minimum requirements of technology. This is a model that was adapted from the University of Aachen, and they talk about the maturity level of technologies. And what it basically means is it first needs to be part of your strategy. Then you need to make sure there's at least some computers in your company, and then you can only look at connectivity. Only after this digitization can you start going into AI and machine learning, etc. So you've got steps that you have to step upon before you can get, to the next level. All right, then the other part, and this is specifically to South Africa perhaps, but future skills development is extremely important. We've got a skills gap between the current workforce and the advanced technologies. Technologies are rolling out too fast, and the universities can't keep up with curriculum development. So there's a gap there that needs to be replaced. There's a lack of alignment between the stakeholders in the ecosystem, the skills ecosystem, specifically between TVET colleges and universities. And there needs to be ways to bridge that gap. Okay, then formal post-school education and training are lagging behind new skill needs, etc. And then also the lack of science, engineering, and technologies, which is basically your problem-solving skills. And in South Africa, there's a lack of those kind of skills. So what we've implemented is a learning factory. And the learning factory is not new. It's been used by the medical sector in the 1980s and 1990s, where they developed learning hospitals where physicians and things like that could actually work on real patients and apply some of the technologies. That was then taken further and applied to the manufacturing industry, where you create a kind of a real-life environment where training can happen without interference of your production lines. And at the CSR, we've developed a CSR Master Learning Factory, where we tried to do that. We started just with some manufacturing cells, and in this last year, we're going to expand it to a pilot plant where we can create a mirror image of a manufacturing cell. All right, just some key differences and the way that the learning factory works. There's obviously theoretical training that's involved, and it's learned by understanding. You focus on the theory around that. But the difference comes in is that we also provide, with that theoretical training, practical training, where people can touch a VR glass. They can touch kind of blockchain, and they can work with it. And they get practical hands-on experience. They can touch it, they can feel it, they can smell it, they can break it if they want to. But it just gives that confidence that they've interacted with the technology. The third part is where we apply to specific areas. So we could apply AR and VR to the manufacturing industry, where we say, this is part of the assembly system and it helps you to assemble products. But at the same time, we can apply to the agriculture industry, where people flying drones and, look at the agricultural side of it. And then the experiential learning is where the technology are actually implemented in industry and people can understand how does it fit into production. Now, the experiential learning in some cases, can be provided by universities and by, science councils like ourselves. But in most cases, that experiential learning only happens in factories, in real factories that are producing. So we're pretty much dependent on industry to come to the party and allow opportunities for some of these students to work in the factories and contribute and understand how the technologies, can be done. And then the last part is the makerspace. And this is where you want to have the community or the surrounding communities involved, where there's a space where they can interact and actually develop applications, for services to the surrounding industry. And some of the examples is in the mining industry, where makerspace is made available for the hosted communities, where they can interact and get trained on the technology. And it really speaks to the entrepreneurship that you want to create and the culture of entrepreneurship. I'm going to share a video with you guys around the CSIR Learning Factory. Let me know if it's not audible.
The fourth industrial revolution is the digital transformation of manufacturing, production, and related industries. It is a new way of organizing and managing industrial value chains. It has heralded the transformation of entire systems of production, management, and governance. Digital transformation has also caused a transformation of the skills landscape, and it is critical that we empower our workforce to access the requirements and opportunities that this transformation brings. To support South African industries and the broader workforce, that includes the youth and unemployed, to participate optimally in the opportunities embedded in the fourth industrial revolution. The CSIR has established a learning factory with the express aim of driving skills development in those disruptive technology domains that are the building blocks to advance manufacturing and future production. The digital transformation themes include the Internet of Things, digital lifecycle management, augmented reality for supplementing human operation, totally integrated automation and robotics additive manufacturing, smart systems for smart infrastructure cybersecurity, big data analytics, simulation, cloud computing, and edge processing. Training is multi-module, some online, some a hybrid of virtual and hands-on, and caters for varying levels of technical competence requirements. The customizable learning path spans theoretical concepts, practical engagement with the various technologies, application of the technologies to controlled industrial scenarios, and experiencing use of the technologies in real production environments. Master site of the learning factory is fitted with different workbenches for the different learning activities. Locally sourced technologies are used as far as possible. This includes state-of-the-art infrastructure for smart manufacturing, human-centered automation, collaborative robotic systems, augmented reality platforms, and a smart house scenario. The modularity of the learning factory allows access to additional equipment and facilities distributed across the CSIR, as well as at industry across the country. Other facilities at the CSIR that are also accessible include the Photonics Center, where 3D printing platforms like Aeroswift are being developed. Other examples are in the Chemicals Cluster, where we are supporting the Biomanufacturing Industry Development Center with the application of 4IR technologies. Another key module is the Cost Technology Center, which...
So hopefully that will give an idea of the learning factory at the CSIR. These learning factories you can implement on a sector level, you can implement it on a value chain level. We had people that are interested that, for their supplier development to implement a learning factory, so you can upgrade all the suppliers to be able to use the learning factory. I then just want to talk about two key technologies for South African manufacturers. It's around X reality or extended reality, and then AI in manufacturing. And for the people that are subscribing to the MITs and some of those technology organizations, X reality and AI in manufacturing, and the combination of the two is tipped as the key game changer in the future, specifically using generative AI in order to work with X reality. And I'm just going to go a little bit in detail into each one of those and just highlight the benefits, etc. Obviously, there's a lot of detail surrounding it, how to implement it, and the approaches that we can, have a more detailed discussion upon. But I'm going to start just with the X reality. The X reality is basically a combination of virtual reality, which is a virtual worlds, plus the augmented, which is the real world with an overlay, and then a mixed environment of both. And all of that together is basically called X reality. The application areas in manufacturing is very well known. It's around the training of staff. It's also around the training of customers on your products. We have a number of companies that goes out worldwide, and they have to deliver products. And every time they need to book out a week, pay all the travel costs, etc., for people to go and train their customers. And with AR and VR and extended reality, you can do that remotely. Remote maintenance and troubleshooting, specifically if you're working up in Africa, etc. You don't always have the luxury to send out highly trained people. You have to rely on people that are still in training, and you can have a supervisor remotely monitoring what somebody is doing. And then in digital product design, you can create a live or a large version of a mock-up of a design, walk through it, see how you need to assemble it, etc. And then obviously in production optimization, where you look at your factory and the layout of your factory, where the forklifts are moving, where are the safety zones, those kind of things that you can actually walk through your digital factory. And then intelligent product manuals, manuals that are wizard-driven, that can help a person looking at your products. And it could also be a potential new revenue stream, for your existing products. So these are some of the application areas for X reality in manufacturing. And just some important considerations. You will see Apple glasses, you will see Meta glasses, all kinds of Microsoft glasses. And I think the important consideration is not all these devices are created equal, and you really need to look at the digital or the detailed spec before you purchase any of those kind of things. They are, at this stage, because the market is still new, there's still standardization is still lacking between the different versions, and that have an impact on the interoperability of these devices with each other. The other key consideration is that with AR and VR and extended reality, it's all about the tool chain. There's not one application that does everything, and you've got different building blocks that needs to be compatible with each other. So your 3D modeling or CAD software needs to be compatible with your game engine. It needs to be compatible with your development kit for your actual headset. And then obviously, if you want to bring in real life or real-time data like temperature and pressures and things like that, you need additional cloud services and collaboration tools. The three most important ones is just to make sure that your CAD environment is compatible with your game engines like Unity or Unreal, and then your XR development kit is then also very important. So these are just some considerations if you want to get into this. I want to show some applications. These are very simple applications that we've done just to bring across the concept. Obviously, you can do, a lot more detail and more complex things. You can bring in AI, you can bring in machine learning, all those kind of things. And, it just adds to the complexity. And these examples that we're going to show now was done by Vuforia with some Dynamics 365 remote assistant and in the Unity environment. So I'm just going to show some applications to give you a sense of how it will look like and how it would work. The first presentation is really around a tutorial on how to replace brake pads of a robot. And you will see it looks at the brake pad replacement. It tells you what protective equipment that you need. And we're now going to fit an overlay of the CAD model of the robot onto the real life machine. And you'll see there's a real life one. It will see, it will fit, it will overlay the CAD. And then the person can start and say, okay, you need to begin. The arrow then indicates to him he needs to loosen the wheel. And the person can then start to start the program. This was done with Microsoft HoloLens, and it's a heads-up display, and it shows them to use a wrench to loosen the wheel and take off the wheel. So it's a step-by-step confirmation kind of program, and it basically teaches somebody that is unskilled on how to replace the brake pads on this specific robot. It will now tell him to loosen and pull it off, and you will see it will then also move to the caliper, and it will tell them to use the Allen key to basically loosen the screws on the caliper to take out the brake pads. So this is a very simple, how can I say, sample of what can be done with it. What is important is that you do have digital transformation. You have a CAD drawing of your vehicle or your product already. That makes it a lot faster and easier. And then it basically overlays it onto what you are seeing. And then you can build the instructional wizard that can then teach the person how to do it. This could also be used for assessment. So if there is somebody that gets trained and it needs to be assessed, it can also auto mark the person, when he does this, because it will compare what the person has done virtually against what is actually required. So this is just an example of augmented reality with an overlay. The next example is more of a VR module, and this one is also focused on creating instructional work for assembly of a product. In this case, it's a small car, and the person is basically taken through the whole process of doing the assembly. It is event driven, so the person must come and it must put a QR code into the scanner, and then it will read that QR code, which is typically your production order, and it will then highlight which jig needs to be used, where it needs to be placed, and then the person will then pick the part from the placement bin. It will place it there, and it will then confirm that it has done that. And then the next part, it will pick that up, and it will also put it there. Each time a person needs to confirm that it is done. It also used the scanner to confirm that the right component was taken. It also includes some quality processes where it basically asks him to take a veneer and measure the height of a certain part, and then the operator basically needs to do an input. Now, this exact same workstation is physically available at the Learning Factory, and this is the virtual training that somebody can do online before they actually come in to use the actual workstation. And you can build these kind of work instructions for your production line, and specifically for unskilled workers, artisans, etc. Coming up. So this is a virtual reality example. And then we're going to look at a mixed reality example, where we look at the repair of a pump. The pump is going to be virtual. It's not going to be a real pump. And you can place the pump anywhere you would like. And then it indicates basically you need to take the screwdriver and you need to remove the head of the pump. And what I want to show here is the ability to import real videos into the augmented and mixed reality domain. So you can, with this headset, you can see a real video. It could be also numbers, figures, or data that you can stream through this mixed reality. And then the person needs to go and execute what they just saw in the video. So if you think about remote applications where you send out maybe a junior technician, you maybe have a senior technician watching the person to see what they are doing. So the applications of this is endless, and you can save a lot of money in support and also create new opportunities for your products going forward. Then the next part that I want to talk about is the AI in manufacturing. We don't have enough time to go into detail, so I'm just going to touch base on this. And I think the important thing is that there's different techniques used in manufacturing, to do AI in manufacturing. The most important one, machine learning, deep learning, natural language processing, and computer vision. And most of these techniques are used in predictive maintenance, quality control, process optimization, supply chain management, and robotics. We've also been a part of a study that were driven by the World Economic Forum that looks at what are the problems with implementing AI in manufacturing. Because there's a lot of tests, there's a lot of experiments, there's a lot of research done on it, but there were very few actual implementation of AI in manufacturing and how it could make a difference. And the study was to look at what are those barriers that are prohibiting this from happening, but also what are the practical impact of AI once it gets implemented and it's working. So these are just some of the barriers. The first one is just a mismatch between operational needs and AI capabilities. What they found is if there is no good business reason or there's no business reason link to the application of AI in manufacturing, it just becomes a technical exercise on solving a technical problem. And this creates a mismatch with the large investments that you have to do. People are not seeing the return on investment. The absence of a strategic approach around leadership. Whenever you implemented AI, you need to have all levels of involvement from your organization. Otherwise, it creates suspicion between the different parties. Insufficient skills at the intersection between your shop floor people and your AI group. There is some mismatch on capabilities and competence. Then data availability and the governance of that data. You might have a lot of data from your factory, but if it's not curated and it is not, there's no governance on it, it's the old story of rubbish in, rubbish out kind of scenario. So there's a lot of projects that have failed due to the absence of governance structures for your data. Then the lack of explainable AI models in manufacturing is that sometimes it's seen as a black box and the data just pops out and there's no understanding or visualization of that AI. And then it still requires significant workarounds if you want to apply different conditions to different scenarios. So this is currently some of the barriers to adoption. The study further then focused on the actual implementation of AI in manufacturing, specifically in health and safety, quality, maintenance, the production processes, supply chain, etc. So the key things that came from it, and it was a worldwide study that was done. It was managed by Turkey, but it involved European as well as American industries. On health and safety, they could get the unsafe incidents reduced by 80%. On the quality side, productivity increased 30 to 40%. Unplanned downtime reduced by 50%. And then operational productivity increased by 20%. And then forecast accuracies reached between 88 to 90%. And then up to 40% reduction in energy by doing energy demand control. So this study really gave us a lot of good insights on how AI should be implemented in manufacturing. I'm just going to focus on the production process part of it and just show some of the examples that we're doing in this space. And for the kind of way that we look at it is a very practical approach. You've got your real world factory and you've got your digital twin that you want to build of that real world factory. And it's very important to understand what are you seeing. So if you look at the iceberg, you really see only the top there. And these are the kind of events that are happening. So, these are the alarms, the machine has failed, there's a blockage in a certain area. So these are the things that you can observe because you can see it in your data, you can see it in your management running reports that you do daily, etc. What is also part of that is these kind of events over time forms a kind of a trend and a pattern. So you will always find that this machine fails, after a long weekend, after payday, for example. And you can start spotting trends, etc. Then there's a deeper part, which is really the structure, the layout of your factory, the way that your processes work, your culture, those kind of things. And then there's mental models, the way that your people think about, the company and what it should be doing. So the first two parts, you look at the events and the patterns, and it tells you what is happening and, what is the effect of that. And you use typical tools to do that. The second part is why is it happening? Because your structure, your underlying layout of your factory, your processes, all of that creates a cause why certain things are happening, why people are not more productive, why are certain machines failing, because there's a certain philosophy locked up into the different areas. You then take that and you say, okay, the first two parts, you can do machine learning and data analytics and come up with the best patterns, etc., for that area. But if you want to look at the structure, you need to look at, the processes that's involved, and you need to look at discrete modeling of tools. And on the mental models where you want to have the human behavior changes, you need to get them into the loop that they understand how the factory functions, etc. So this is our kind of belief model on how we tackle digital twins and do process optimization. It just helps to demystify this black box called AI. So on the one side, we're looking at getting the users involved, and typically when we start with a company, we ask them for their blueprint of their factory, and we have a tool which we call the factory layout tool, where we just map out the whole factory, where stuff are. And typically you do this as a management team so people can see, where and is what is happening. And then we typically take that and we build a 3D model. We've got a specialized tool that extract the relevant info and then create a 3D model of your plant. So you can see where are the forklifts driving, how the walls look like, etc. And then from there onwards, we start to adding the sensors, etc., to be able to build a digital model of your factory. I just want to give a quick demonstration on a tool like that. And can everybody see my screen? So this is a digital plant that's currently happening. This one was built by Siemens, and it's a kind of assembly line with trucks coming in. And the way that it's modeled, it's got a forklift. You will see it will offload the cargo from there. It will go onto the conveyor belt, and you can see some of the things happening. We've got people here moving, doing certain tasks. And the granularity that you can do here is you can even model on how lazy they are. Is it a night shift? So things are going a lot slower. Day shift, people are perhaps more sharper and they can, are more productive. But you can even model the people and the typical tasks that they are doing. And then obviously here you will see where the product are dropped onto the conveyor belts, and then it will go to different parts of the factory. So you can really get down to a granular level. But the benefits of this is real time currently. At the back, you've got your warehouse and then the shipping. But what if you want to do and you want to change some stuff and you need for this to run faster? And having a digital model allows you to do this a lot faster and simulate a couple of days in an hour. So it will show you it's about one truck that arrived. This is the process where it goes through. Your warehouse is filling up, and it's basically going to fill up the trucks, etc. So you can accelerate it, you can stop it, you can add additional lines, you can check the buffers in your manufacturing process, and you can optimize it. And it allows you a lot of flexibility on understanding how does your plant work, etc. So this is just some of the tools that we've got. You can then also do an energy balance across your plant, look at your electricity usage, your net zero carbon, you can predict that, etc. And these are some of the tools, that's available that can do these kind of things. I think that's it from my side. Yeah, I think that's it.
Wow, Rian, that's so insightful and helpful. Again, remember to share your questions for Rian in the Q&A section. And thank you for that. I'm going to ask Professor Grace Kanakana to open your camera and start sharing your presentation. And there's going to be some pressure on you to go through your presentation far quicker than the other presenters, but I hope you don't feel the pressure. Can you hear me?
Yes, I can hear you. You can hear me, right?
We can hear you, yeah. So we're passing the presentation through to you.
Okay.
She's going to speak to us around the QT as a case study for skill development in the same set of skills. And then I'm happy that the presentations speak to each other. And so what is the current reality learning institution that's producing future manufacturers? Thanks.
Thank you very much. Can I share my screen? Oops. Am I sharing?
Thanks. Yeah, we can see your screen.
Okay. Thank you very much. Okay. Good morning, colleagues. As it has been said, my name is Grace Kanakana-Katumba, and I'm here to share with you in terms of what we are doing at the Tshwane University of Technology in terms of skills development for the manufacturing sector. So I think the previous speakers have actually touched on a lot of things that align to what we are doing as an Institute of Higher Education. This is my presentation outline. I won't go into detail on that. But as a way of introduction, maybe let me start by talking a little bit about our university. Most of you probably have heard about Tshwane University of Technology, which is in Pretoria, just close to, we've got many campuses, but we are based on the campus which is close to Maravastad. In there, we've got about 8 departments, which are mechanical, industrial, electrical, and chemical and civil engineering. And we also have got a bit of a built environment, which is building science, geomatics, and architecture. We've got about plus or minus 9,000 students. And the work that we are doing in terms of skills development, it really touched base across all the spectrum. And as we focus on manufacturing industry, because it's one of the main, I think, economic driver at the Tshwane region, that is why we decided to embark in this particular project that I want to share with you about. We all know in terms of the background of the manufacturing sector, contribution to our GDP is quite significant, and it is expected to grow if we do all the things that we need to do right. That growth actually, obviously put pressure on the capacity building that we as Higher Education Institute are actually, doing in terms of ensuring that the graduates that we produce, they can be absorbed in industry and they are really ready for being employed at any industry that they find themselves in. If we talk about the automotive industry in particular, we take that Tshwane is the hub of automotive industry. We do know that there's some automotive industry in Eastern Cape and in Durban. However, we view Tshwane as the hub of automotive industry as such. As a higher education, which are an University of Technology, we're supposed to be focusing on applied sciences. We actually take the mandate to say we need to contribute a little bit better in this industry. And hence, that is why it is shaping the type of projects that we are going to talk about just now. We have learned from the presentation from Tabi and Rian passing before that there is a really need in terms of skills within the manufacturing industry and the automotive industry. And we have also learned that the technology is actually growing very fast, and we as universities are not actually able to review the curriculum fast enough compared to the way the technology is growing. So as an institution, we actually had to ask ourselves, what are other ways that we can actually do in order to ensure that we integrate these new technologies to the curricula in a way that is not going to disturb the current curriculum, and that at least the students that we produce, they are ready to be able to be uptaken by the market. Of course, if we look at the current curriculum development, it takes us 2 years for us to go through the whole process, in terms of internal approvals, CHT approvals, DHEAD CHT, and also the Engineering Council. So in order to ensure that we continuously improve and integrate the technologies that we have that are coming through so quickly, we have to look in terms of where can we actually do this, in which areas can we actually improve. These are the skills that they say that they want can I say, a graduate of the 21st century to possess. So if you look at it, they are, obviously very diverse. Technical skills, software and digital skills, problem solving, critical thinking, communication, customer focus, adaptability, and continuous learning. And those are the things that, they seem to be very easy as one is talking about them here, but integrating them and ensuring that the students that we produce have possessed all those. I think that's where the challenge of higher education is at this point in time. So I'm quite happy that Rian has touched on terms of the learning factory, because if we look at the literature and what we're trying to do as we move forward as the University of Higher Education, is really to partner and with industry so that we can be in a space where we can have these learning factories where our students can go and be exposed and engaged in, because it's through these learning factories and teaching factory, extended realities, that if we can actually expose the current cohort of students in our university to, when they finish, they will be able to get into your organization and they'll be able to be effective employees. We won't need to spend 3 years training them for them to be effective engineers. So as a university, Tshwane University of Technology, we have been doing a lot of activities. We have got a research center at Tsela, somewhere in Hartfield, where we pilot some of technologies like virtual reality, where we use that to create a training material to equip students and also employees that are already in the industry. And what we have found from the results of this initiative is that really the students have actually shown significant amount of learning experiences when they're actually exposed to such activities. We also have another approach that we call it a project-based learning. We are implementing the approach that we call the CDIO in our teaching and learning or in our curricula. So this approach has been implemented worldwide throughout the world, and I refer to the study of View here 2018 that says that really this approach it enabled the student to solve real industry problem in the classroom. And I think if you look very clearly or closely, it's really a small version of the learning factory because here you bring, whatever concept that you want the student to learn and understand. You give them a small demonstrator of that concept and you ask them to really start design the solution for this problem that the industry has, from the beginning. Working together as teams, they actually come up with different designs or different solutions to solve that particular problem for the employer. Then they're able to use different technologies as well. So they start from the conceptualizing and then they design and they implement and they operate this solution and they demonstrate that the solution can actually work in a real life environment. So this approach is quite a powerful approach that we are also piloting in our manufacturing models throughout our university. We've got about 560 students that go through this approach, and as a result of the funding that we received from the Royal Academy of Engineering. The project that we work on right now, which is actually funded by the Royal Academy of Engineering, is what we call the electric vehicle technology integration into the curriculum. And this project's aim is really to integrate the EV technology into a manufacturing and the design model in our in higher education institutions. Now, we are doing this at TUT, but we are well aware that South Africa doesn't rely on students that actually graduate from TUT. They rely on, the capacity that's get produced by many, University of Technology. So we decided to team up with other University of Technologies in order to integrate this into their models so that the students that actually also graduate from those universities, they are able to have this, knowledge and skills. So this project, we're partnering with the Durban University of Technology, Cape Peninsula University of Technology, University of South Africa, and we are also working with three collaborative partners, which are international partners, which is King's College London, Aston University, and University of Warwick. And then we needed an industry partner on this. That is why we partnered with naamsa as well on this. So we realized that the solution for this problem is not going to come if higher education industry or academia, they are working by themselves as a standalone entity. We need industry like naamsa, we need industry like CSAR, we need industry like your industries that we can work with in order to make sure that the students that we produce, they are ready for the world of work. Thanks to the Royal Academy of Engineering, we are able to implement this project. Where we this project, we got an opportunity to train academic staff members in terms of ensuring that they know. First of all, we train them on these approaches that we want them to implement. The one of learning factories and the one of the project-based learning, including the code approach. Why is it important? If the lecturer or the academic staff members are not knowledgeable, there's no way that they will be able to create that significant experiences in the classroom. What the student gets is what the lecturer actually, prepare and give out and facilitate. So these workshops are quite successful, and we have identified two models where we are integrating these AV technologies on them. And then these models, they are actually going to be part of the curricula. And we don't actually need to wait 2 years we can actually do it now so that we can actually be fast and react quickly to what the market needs. We also decided to give our student an international exposure. So the COIL approach is using technologies, digital technology. Although the university have got a learning management system, then we're able to pair our students with international students so that they can solve certain problems, so that they can experience, there can be this cross-cultural learning experiences, there can be better way to build teams, there can be better way to communicate among themselves and sharing ideas. So this project as well is progressing very well and with our international partners. And we hope that exposing our students to this type of projects, it enables them to really go out as and become an effective graduates when they finish. Some of these students, when they finish, they'll get involved in supply chain industry. Well, they'll be sent all over the world. They'll be managing virtual teams throughout the world because the world of work has changed. So we have to actually do that right now in the classroom so that they have this type of experiences. We build a community of practice for academics, those that are interested in project-based learning and electric vehicle technologies. And in this community of practice, we are able to, share technologies, the latest technologies, give guidance, mentor, and direct the conversation, from the academics. So I think it would be very great if we can get also industry members that are interested in this area to be part of this community of practice, because the more we share the knowledge, the more we have this conversation, the better the quality of the student our academic produce. This is just one of the demonstrators that we use in the classroom when we do project-based learning. And this is just, this mini vehicle. It helps us to demonstrate to the student what does it mean that, powering a vehicle using solar energy, using hydrogen energy, using direct, electricity. Because, we don't have sufficient laboratories and we don't actually have opportunity to take all the students to industry. In fact, I did some inquiry with NAMSA to say where exactly in South Africa are we producing the fully EV vehicle at this point in time? We don't have. So, but I know there's plans to have one. But then until that time, how do we expose the students into this technology tangibly? So that's where we actually come and get these smaller kits, laboratory kits that we give to students to create that type of learning experiences that the student can handle with. One other area that we notice is if we, as I indicated earlier on, Rian said it very well, higher education institute, they are not changing fast enough. The technology is changing quicker than we. If we were to review the whole curriculum, it's going to take us too long for us to be able to upgrade or to upskill our students, and also the lot of capable, staff members which are in industry right now that need to upskill their knowledge from the qualifications that they received maybe 5 years ago or 10 years ago. So we have actually put together a short learning model for electric vehicle powertrain short learning model. But we also have got a lot of other short learning programs that we developed that can actually be used to empower or to upskill those, some of the staff members that are able to do this. And the nice thing about this is they don't have to come to campus. They can use digital technologies that we have. They can do this virtually, and they can upskill their knowledge. I think it's very important that continuous learning take place. So we are catering here for our students and those that are already in industry. So what is the future projects that we're working on right now? We want to look at the value chain analysis and identify the key markets needed to support the electric vehicle market in South Africa. We've got a postdoctoral student in this that we're going to appoint, and we hope that this research will help us to understand, what is it that which value chain or which area do we right now, possess the skills and the know-how, and which ones that we don't have the skills and know-how, and with the hope that those results will then inform our curricula. It will also inform our short learning programs that we are going to develop, and hopefully it will also inform, the investment decisions that maybe our government will gonna make in terms of ensuring that they capacitate that value chain where currently maybe there is no capabilities. We are working with all these 3 universities. We are also working to put together a degree in automotive industry. We visited the University of Warwick that they have actually this degree, which is in automotive industry. They've done this, I think, for the last 4 or 5 years, and they actually offer it in a form of a degree in automotive industry, which is an apprentice degree. And how do they do this? They actually, the students that are working full time, employed by an automotive industry or manufacturing company, and then they're busy at the same time, taking this degree with at the university. So the university gives the classes virtually to these particular students or delegates, and then these students, they go and apply what they've learned at their work environment. At their work environment, they've got a mentor will actually assist them to make sure that they go through what is required practically in terms of practical projects to apply the less or what they've learned theoretically in practice. So this model, we think, is actually a powerful model, and I think this model we think that we can be used to upskill many of our staff members that are currently maybe in our companies that we know that in the next maybe 3 or 5 years they're going to be redundant, but they've got capability to be able to grow and to become, or to be able to acquire those skills which are needed for them to advance or to play a meaningful role in the 21st century when the new technologies kick in. So we do hope that will enable us to also integrate a lot of technologies in our curricula, and we are, as I said, that we are in the planning stage on this, on design stage on this. We really need the industry to also come and partner with us on this, so that we can be sure that whatever we put into this curricula is really address industry needs, and not only can it be beneficial to the students that want to get a degree now, but also those ones that already have a degree that want to upskill themselves, and also those people who are working right now, but that want to actually maybe change field. It has been said that by, in 21st century, people will change careers 3 or 4 times. So I think this will actually be maybe a mechanism for some of the staff members to change to do something else. In terms of future project, again, we also today, we have learned or we'll get reminded of the learning factory that the CSIR has. We would like to also ensure that we have this type of technologies or laboratories that our students can be exposed to. But I think for now, partnering with industry that have this type of technology is what we are looking for. So if we have this type of technology which are available that our students can be exposed to, we definitely will be willing to take on that opportunity and ensure that the students that we are producing them meet the requirements. Yeah. We are also going to have a chair in automotive industry, particularly focusing on skills. We are applying funding for this from Royal Academy of Engineering and also NRF. And we are hoping that if we secure enough funding, then it will also help us to build a lot of capabilities in partnership with industry as we move forward. So in conclusion, we understand there's a huge need in terms of the students that are coming from the higher education institute that needs to be empowered on what the industry need. And there's also a huge need in order to upskill the current, cohort of staff members that are employed right now in the industry. And I think industry alone won't be able to do it. Academia alone won't be able to do it. But I believe government alone won't be able to do it. But if we really use that tripartite model, and 3 of us we work together, then we'll be able to develop these solutions and make sure that we upskill our people to be able to be effective and grow the industry to the right level that it needs to get to. Yeah. So thank you very much.
Thank you, Prof. Grace. I'm going to ask my technical team to cue all three of you for our Q&A session. If you could do that, and you can stop sharing, Prof. Thank you. So as we cue the three of you back on screen, we're going to be able to take one round of questions. You have about 3 minutes to respond. Some of these are quite deep questions. Can you have your camera, keep your camera on, Prof. Grace, and same to you as well, Rian. There we go, perfect. I'm the one who's off my camera. Okay, great. I think the first question is to you, but don't answer it now, note it down, Dr. First. The idea that in South Africa we've got tier 1s and tier 2s, and based on those three scenarios that you explained around net zero, the pressures that are on suppliers being responsible for what you said is 70% of emissions. How does sponsorship look like? Lower tier suppliers are often constrained in terms of accessing financial support and driving this digital transformation, and these are critical for the success of OEM. So what has been the support for these lower tier suppliers that are responsible for so much net zero burden that is faced by an OEM? And does government come in? Is it university that support to come with solutions to help them navigate that one space? I think that's where it comes from, that particular question. Rian, let me throw this at you as well, although it was also thrown at Dr. Wilberforce. The idea that in South Africa we've got these SETAs and there's fragmentation. No one is the authority on future skills and what they are and how they are structured. And in that fragmented scenario that we have in the country, where should we be benchmarking? What should we be doing? Are the SETAs even relevant? There is the new QTCO approach focused on occupation, a right model to center South Africa in driving these advancements, especially the skill development needs that we have as a country. And same to you, Dr. Grace, consider what an answer could be on that SETA relevance and QTCO relevance, and whether or not should they be the drivers of this transformation. And there is a question around Brexit, asking since Brexit, investment may have gone down, has been on the decline around industrial activity. What is the reality on the ground? Do we see that digital transformation is bringing back investment? Or what is the new Brexit reality? And there's a push in South Africa as well that 50-year-olds perhaps should not be in the world of work. And we're talking about an X amount of over 65-year-old Dr. Wilberforce that are leaving the workforce, but we still need their expertise, and augmented reality is how we keep them in the workforce and training the newer generation. Are we seeing a resistance by 50-year plus in South Africa, in a South African context? So from a South African context, do we need our 50-year-olds to be living the world of work? And do we see this X-reality solutions that you presented earlier, creating a preservation of knowledge so that we could still have our those that are living the workforce still remaining relevant for the future generations to learn from? I hope that we have captured your question nicely there. And then the other question that we have, Rian, and to you as well, Dr. Grace, is the whole learning factory thing. That what then happens when our learning factories are not aligned to what's happening in the industry? So we produce a graduate who's a proper product of the learning factory, but because of IP, the reality and one OEM is different from the reality from another OEM. How do we sell a learning factory as a competitive platform that still that OEMs can buy into. So, and I know Rian used the word come to the party, but rather than get them to come to a party, we get them to be early adopters of learning factories because it enhances their competitiveness. How do we reshape that conversation so that we keep our OEMs interested in using learning factories and interested in using these solutions that we're coming up with from a development point of view, and that they see them as driving competitiveness for them. And I think that's the one question that we still need to think around. And finally, this is from me. It's the idea of NAMSA is partnered with learners. How do we keep these technology topical at high school level as areas of interest so that we could get our young people to start thinking around these technologies as a career path for themselves and to keep attracting young people into this world that we've just spoken around today and that we've discussed today. So if you fancy and answering any of the questions that are asked in that one drive, you've got about 3 minutes each to just reflect on all those questions, and then from there, we will close the conversation this morning. So, Dr. Wilberforce, I'll start with you. Rian will then come up to you, and then Professor Kanakana, you'll be then the last one to go. Thank you.
Thank you very much. So I made a note of some of the questions, and let me start with the one about the 35% decline, investment decline post-Brexit. The first one is UK and the EU continue to still have some trade agreement to ensure that even though the UK has left the EU, it does not suffer in terms of its economy. And again, there's also digital trade and free trade agreement that is still in existence to ensure that, again, post-Brexit, the economy of UK becomes sustainable. And again, there's also a government policy on national data strategy where the government launched this in 2020, mainly to harness the power of data to ensure innovation and economic growth. There's also funding future opportunities that the government has rolled out to ensure that even though in 2022 there was that level of deficit, there is that economic bounce back as a result of this initiative. I'd like to also quickly touch on how best to make AR attractive to the younger generation. First of all, the whole idea is it's an immersive training. And so there's that flexibility, there's that interaction that can easily catch the attention of the younger generation. And it's also a form of gamified learning, as Ryan rightly suggested. And so there's that level of interaction that can also be brought to play as a result of the student engaging. But key issue that I want to touch on is in order to bring the 50s up to speed, it has to be gradual. So the tasks on these AR shouldn't be something that is quite challenging, and it should also be a personalized learning. The other thing is to highlight it as a tool for safety. So once safety comes in, everybody becomes interested in the whole process. There could also be some peer-to-peer mentoring, which could be also another means of getting the older ones to rather coach the younger generation once they get to appreciate the importance of the technology. And of course, the recognition and incentive. So I think I'll end here, and that will be my reflection on the questions. Thank you.
Thank you, Doc. Rian, have a jet?
Yes, so I'm going to start just with the fragmented skills development question. And I also just want to make it clear that the Learning Factory is very dependent on an ecosystem that's surrounding it. It can't live in a bubble. It needs higher education to be part of it. It needs industry to be part of it. It needs labor to be part of it, and it needs the community to be part of it. So the Learning Factory doesn't belong to the CSR. We hosted the Master Learning Factory that does the research in learning factories, but we're in discussions with universities as well as other higher education organizations to establish it at that universities, with the aim that it's hosted at the university, but it's owned by the industry. And I think that covers the second questions around, how do you make sure that this works for the industry? The industry needs to be part of the governance structure of a learning factory. They need to guide and tell you what are the areas that you should be focused on. Because at the end of the day, the learner is a product, and that product needs to be fit for purpose, and they need to get running on day one. So it's very important to orchestrate this whole ecosystem to work together. Then there's a question around IP considerations around learning factories, and are you going to give away your IP? And I think the model that I can maybe, as an analogy, demonstrate is that we are working with the mines, and the mines got hosted communities surrounding them, and there's other mines in the areas. And when we spoke to them about augmented and virtual reality, they said that there's very specific IP that they would keep close to themselves, and they won't teach, other people or make that available. But there are parts of that technology that could benefit other minds, and they're willing to share that. And that's a kind of a sharing mode where the non-competitive info and courses are shared, with the rest of the communities and the minds. And that's the kind of way that you can, go around, the IP issue. You can have a learning factory that's only focused on the competitive IP part, let's say for a OEM, but then there's also a bigger open part where they're willing to share some of the more general knowledge. Then the other thing around also fragmentation is we need to start thinking about micro credentials, not just here's a degree for you, but what are those micro credentials? So you've learned how to use the AR VR set, so you get a badge for that, and you start building up all these micro credentials that then are acknowledged by industry. And I think that's very important. Whatever we do in the learning factory need to have the support and credibility and approval by the industry. Otherwise, the learning factory would become irrelevant. I think I'm just going to stop there for now.
Thank you, Rian. Prof, the macro credential, maybe it's a good springboard for you.
Yeah, so macro credential in engineering education, we have been actually having this discussion for a while. We did a research on that. The challenge that we actually face currently in terms of macro credential is the fact that those credentials, they are not accredited. Hence, they're just the add-on on the current qualification right now. So what we've done at our Tshwane University of Technology is we actually identify key modules that we can actually add industry certification. So particularly modules in automation where Festo is a lead and Siemens. Then we actually have industry certification on those models. And when the student finish that particular, unit model, then they get the certificate, and then it augments their qualification. That's all that we can do at this point in time. And I think it's an exciting time that we are living in, because macro credential they are growing in higher education space. This conversation to get, professional bodies like EXA to consider them as part of the qualification. There's people which are lobbying, they're saying that our current model of recognizing of a prior learning, RPL, that is no longer effective. So we need to change with the future and include this digital technologies to do that. And macro credential is really one of ways to be able to do that effectively. So yeah, I agree that we need to make sure that we pair in what we do in the learning factory with the macro credential that leads directly to what is being done maybe in the classroom, whether on the kind of degrees that we're offering now, or on the new degrees that we like to offer in the future in terms of the apprenticeship degrees. I'm going to move right on to the issue of, I think I'm going to put it as articulation and alignment, because also, again, there's also conversation of what is happening right now in TVET. It doesn't align with what we in higher education environment are actually doing, and a student that complete in TVET, how do we make sure that that student can seamlessly articulate to a higher education institution, and and they go out and become a productive employee out there. So what I know what is happening in this space is right now the Department of Higher Education is working on a new framework that's going to be implemented soon. That's actually changing the current, I think, the framework of TVET colleges. And the main objective is to ensure that there should be some kind of a, alignment of what is happening in Tibet and what's happening at the higher education institution. And that will also spill, I think, to the CTQOs and the CETAs. If you ask me, I think what I've learned in UK, if our CETAs can actually, implement that, it will really make them more relevant. Because what is happening now in UK, the degree in apprenticeship is being funded by some of the funds that is actually right now is taken by our CETAs. So in industry, they contribute a certain percentage toward the skills development. Now, instead of that, money goes to only professional development training within the organization. It can also be used to actually upskill that particular staff member to acquire a professional and actually a degree from higher education or from a TVET college. And I think if they actually do like that, they will actually remain more relevant. Because right now, the content of what they're actually having, it might not necessarily be, changing as quickly and as rapid as our technologies that we are actually right now changing. But as I remember very well, CETAs or industry, this play a very important role on what CETAs are supposed to actually have in their curricula, right? So again, it also speaks about industry speaking to academia, speaking to the communities around, so that what is there, as a profile or portfolio that the CETAs are funding, it is the technologies that we want our staff to actually get or to learn at the end of the day. The last one, it had to do with how do we keep the technology relevant and for young people. I mean, I'm in higher education because I'm passionate about developing young people. I'm passionate about developing also the ones which are undergraduate. But I think we can never stop talking about this. I mean, we have to find some mechanism, some type of systems, communication system that our young students can actually, and that they like listening to. Right now, they are on Twitter, they are on Facebook, all those other spaces that we think that they are actually boring spaces. But I think we need to develop this content about the future technologies and let them see that they're not only good for, for them to to listen to a TikTok message. So they can use this technology to really upskill themselves and make them interested in engineering, for example, or manufacturing or automotive, using those platforms that they really enjoy to spend time at any given point in time. We also need to understand that the way they learn is not the way we learned. So we need to make sure that we change the way we communicate to them, the way we package our portfolios to make it attractive to them so that they can actually find themselves in this future that we are trying to build. Thank you, Chair.
Thank you. So we're going to pause our session for today here. And thank you for you three guests, Dr. Kabi, Rian, and Prof. Grace. Rian, maybe because of a mistake, I didn't put a title there. I apologize. You know how professors and doctors always want to be referred to in their titles.
No, we are fine with Grace.
So yes, we're gonna pause it here, ladies and gentlemen. Thank you for attending. Now I'm going to ask Komotu to take over the screen because I want to share two announcements before we leave the call this morning. The first announcement has to do with Brand's book. We remember that we said that hundreds of you that were able to attend this particular program, it's in entirety and all 4 sessions. So our system, we've identified the hundreds of you recipients of in the driving seat from brand, and this particular book will be coming through to you. Look out for it. So look out for a communication asking you for the delivery address, and then we will ship it. That is the first announcement. So congratulations to all that were part of the series and that enjoyed all the 4 sessions of the series. And we are grateful that you guys were part of us, and thank you for that. Now, the other one, which again he's going to share, is Komoto. It's the SA Auto Week. The SA Auto Week is coming next month in Cape Town, the CTICC. It's going to be between the 17th and 18th in all earnest. So, which is the 2 days of the thought leadership conversations and conferencing that we're going to have in Cape Town. Now, I've got good news. In today's call, we had 150 presenters from this particular session. Now, as of today, there's an early, there's a special ticketing, discounted ticketing that's made available to the public to attend the 2 conference days of the SA Auto Week. However, for the 150 of you, or I think at some point we had about 156 that were part of this call today, a complimentary ticket to attend the 2-day thought leadership conversation in Cape Town is also going to be made available. If you are interested in attending the SA Auto Week, you've got a complimentary ticket to attend the SA Auto Week on NAMSA. The catch though is that the complimentary ticket is for access into the conferencing on the 16th and on the 17th. But you have to make your way to Cape Town and you have to have your own accommodation. But the conference ticket is given to you as complimentary by virtue of attending today's session. Now, if you really want to register your interest in that complimentary ticket, email events@namsa.co.za, events@namsa.co.za, and confirm that you are part of the session and you want that complimentary ticket, and they will confirm your attendance of the SA Auto Week. That is the third announcement. That is the second announcement. Now, the third announcement is that today, look out at our NAMSA social post. We will be publishing 2 RFPs that RFIs that we require from you. The first RFI is for a hackathon. This hackathon, the finalists will also be invited to attend the SA Auto Week, and it's to protect the key of a car which has got a radio frequency. So we're asking our student community to think about Faraday and think about everything that they've learned around radio frequency and how to stop a car key from being interfered, because there's an increase in crime through interference of the radio frequency. And how do we protect a key from being interfered with? And how do we protect a key from being cloned? So we're doing a hackathon for that at the SA Auto Week, and your solution can then be commercialized, and you could then you could have an invention that we're commercializing together with industry. And the other one is for everyone that has been part of this masterclass and then asked the question, how do I become a supplier? So if you have an innovation that you've worked on or you've innovated, you can then give us a proposal on your innovation, and you can then form part of the auto industry Shark Tank, also at the SA Auto Week. And if your idea and the visibility of your idea makes sense, you get a chance to speak to investors, auto industry experts around your innovation and what you think is a solution. And if you're lucky, you could be a supplier in the auto industry. So this is where we pause, and those are some of the announcements. Thank you for supporting this masterclass, and this is where we say it's a wrap. God bless you. Amen.